let's begin. And again, I mentioned this last time. For this particular problem, to construct a frequency distribution, they spell it out for you in sense that they tell you how big of each class they want it to be and what is our starting point, which is, again, our starting, which is our lower class, will be 55. And every time we jump, we just add 5 in it, right? So this is what we have, which is every time we jump, we add 5 to it. And like I mentioned, just a reminder from last time, to find the upper limit, we just use one unit less than the next lower limits, right? So again, as I mentioned earlier, or if you look at the video, I told you guys that it depends on your data. If your data does not have a whole number, does not have a decimal, then your upper limit will be just a whole number. If your data have a decimal, then your data will have, your upper limit will be 0.9, which is next to the upper limit, right? And again, to find the frequency, we just go in here and we just tally our data. And if you go and you tally your data, this is what we have in the sense of all of your data. If you add all of your frequency, it should be equal to 60, right? So we did this last time, and I believe this is where we stop. We pass this thing here. Your frequency histogram, basically you go in and you put in each of your frequency, how big of your frequency between 50 to 60 and so on. And I mentioned that this is not symmetric, even though it looked like it's symmetric, but because of our data, we have a few further to our left-hand side rather than on our right-hand side. So it's not really symmetric in the sense. And again, I believe this is where I stop in terms of ask you to construct your relative frequency. And your relative frequency, reminder, your relative frequency is basically all you do, you take each of your frequency, divided by the total frequency, which is, again, for the first item, we take 1 divided by the total, which is 1 divided by 60 to give us 0.017. And again, we take 0, which is 0. We take 4 divided by 60 to give us 0.067, and so on and so forth, which is 11 divided by 60 and 23 divided by 60, and the rest of your frequency, which is, again, this is your relative frequency in the sense of your item. So once we have this, again, they can ask you to construct your relative frequency histogram. The only thing different is instead of frequency, you put in the decimal. And like I mentioned, your relative frequency does not, or is always a decimal. It will never be a whole number except 0. Okay, so let's take a look at this problem here. And if you look at this problem, I mentioned earlier in the previous problem, when they ask you to construct a relative frequency or a frequency, they tell you what the class width and what data to start with. If you look at this thing here, don't worry about your data. If you just look at this thing here, they ask you to construct a frequency distribution with the approximately 11 classes. So if they give you this thing here, they don't spell it out. They don't tell you, I want this big of a class, this. Now they only want to know, well, construct me that is include 11 of the class. So if you construct an 11 class, which is the first thing we need to do, is we need to find the class width. And to find the class width, ladies and gentlemen, to find the class width, this is what you need to do is you look at your data, scan through your data, look at your data, whatever the highest data, you take that data and you divide it by the number of class you want. So in this case, they want 11 class. My highest data is 52. I take 52 and divide it by the total number of class that I needed, which is 11. I have 4.727. And like I mentioned to you guys, in this class, there are a few different rules of routing. Because we deal with discrete data, because we deal with the number of subscriber, because we cannot count half of a person or half of the subscriber, looking at this thing here, for your number class, you always go up to the whole number. you always go up to the next whole number, even though if, for instance, if you have 4.27, even if it's 4.27, you still go up to 5, okay? So because of the number of the class width, you have to go to the next whole number, okay? So anytime we deal with discrete data, reminder, discrete data is a counting data, right? 1, 2, 3, 4, 5, 6. Anytime we deal with discrete data, you always go up to the next whole number, okay? And your rule, we don't hold that rule. Even if it's 4.1, you still go up to 5, okay? We want to overestimate rather than underestimate, okay? The other thing is, for this author, how do we determine the first lower limit? So the author asks you is basically look at your data. Whatever the smallest data, you always go down to, if your smallest data is 2, you go down to 0. If your lowest data is like, say, let's say 14, you go down to 10. So he always go down to that 0 number. If your smallest data is like 9, then you go to 5, okay? So basically, he always like to start with that either 0, 5, 10, 15 item. So look at this thing here. Looking at our item, the smallest data is 2. So the first lower limit will be 0. We go down. He wants to go even. He don't want to use 2. He wants to go down to 0 just to make it a balance of item. Okay. So again, we did our class width, which is every time you jump, you need to add 5 units. Which is every time you jump, you add 5 units. Just coincidentally, that this class width is the same class width as before. Question? The 11 is the number of class they want right here. For part A, they ask you, because they want 11, if they say 12, then you take 52 divided by 12. So is the number of class that they want, and that's how I come up with the 11, because part A. If they say 7, then I take 52 divided by 7. So they tell you, again, for this, if you do the homework, they have only 2 options. Is they either tell you how big of the class width is, and then you go in and then you start, every time you jump, you add that many class width. For this problem, they don't give you the class width. They give you the number of class they want. So in this case, if they give you the number of class that they want, you have to follow the class width. So in this case, the reason why I use 11 is because they want 11 class. If they say they want 8 class, then I take 52 divided by 8. Okay, so you just divide by the number of class that they want. And similarly, the upper limit, like before, is just 1 unit below the next lower limit, right? Which is my upper limit. The next number will be 4, right? And then again, every time I jump, I need to add 5, which is 4 plus 5 to give me 9, or 1 unit below 10. And like I mentioned to you guys, if your data have a decimal, in this case, my data is a number of subscriber. I don't have a decimal. It's a discrete data. If your number is a decimal, then you have to go to 4.9, 5.9, and so on and so forth. If it's a decimal. If it's not a decimal, you just go with the whole number. Okay. So this is what I have. And once you have the class, you just go in and you tally, right? You tally your data. You look at your data and you ask yourself, still have question with number 11? Everybody see how I have number 11 here? Anybody see why I divide 11? I saw in chat you guys have question.
Nah, I don't understand.
Again, the reason why I have number 11 is because part A right here, they asked me construct a frequency distribution.
So it's given to you every time?
What's that?
So is it given to you in these type of questions? Is it always given to you?
Yes.
All right, for sure. Thank you.
Yes. Again, like I said, they have 2 options. If you look at this thing here, like I mentioned, you have 2 options. If let's go back to the previous problem, right? if you look at this problem right here, part A, for this particular problem, they say construct a frequency distribution using the class width of phi and using this item, which is, I told you, if they give you this thing here, they spell it out for you. They will tell you how big each of your class is and where or what number to start. And if they give you this information, then life is good. You just start with the lower limit, and then you just add the class width, right? So this one here, they spell it out for you. And then we run into the problem that we have, which is the other scenario is if they don't give you the class width, right? What about this problem here? They don't tell us what is my class width. They don't tell us what to start. They just tell me construct the frequency distribution table with the approximately 11 classes. And that's where number 11 come in. Like I say, if this number were to be 8, then I divide by 8 and not divide by 11. Okay, so everybody see that? Now, the next question they ask you or to do this, which is again, like I mentioned, once we have the class width, we always route up to the next whole number. Once we have this thing here, which is again, every time we jump, we add 5 units, so on and so forth. And once we have this thing here, now to find the frequency, all we do is we go and tally between 0 and 4. Between 0 and 4, how many data I have, which is in this case, between 0 and 4, I have 5 data, and that's where my frequency 5 came in, right? The frequency is basically between that number, between that group of number, how many times does those data appear? You just go in and you tally up your data, which is if you go and tally up your data between 5 and 9, we have 6, and so on and so forth. Okay, so question with this frequency item that we have, which is you go in and you tally each of your individual data, and once you have each of your data, those are your frequency. And again, to check your answer, basically you add your frequency up, you add each of your frequency. If it's equal to 40, most of the time you do it right. If it's not equal to 40, you might miss your data somewhere along the way. If it's more than 40, you might overcount some data, right? So again, unless you overcount some and you undercount some, then you have correct number, but mostly you only make one mistake, and that's where the number is different, okay? So question with this relative frequency, or not relative frequency, the frequency distribution table here. And now the second question, which is part B, or not part B, they part C. Let me do part C first before I do part B and part D. Part C, they actually construct a relative frequency distribution for the same number of class, right? Which is to go back to your frequency, your relative frequency. The only thing we need to do is we need to take the phi divided by the total, which is again phi divided by 40, which is phi divided by 40 to give me 0.125. You take 6 divided by 40, and so on and so forth. Okay. So question with this frequency and this relative frequency here. Any question with this frequency and this relative frequency? The next two items we have is how can we construct a histogram, which is again your histogram reminder, your histogram, your frequency will always be on your vertical item, and your data will all be on your horizontal item, which is again from 0 to 5, 5 to 10, and so on and so forth. Which is again, this is what I have is 0 to 5, I have 5 data, 5 to 10, I have 6 data, I have 8 data, 9 data, and again, so on and so forth, which is, this is my histogram. And the last thing is the only thing different between a relative frequency histogram versus a frequency histogram is instead of list the frequency, you have to list the relative frequency, which is again, I start with 0.0 and then 0.05, 0.1. My highest data is 0.225, which is I go up to 25%. And again, it's relatively the same histogram. The only thing different is instead of using a frequency distribution, we use a relative frequency as our item here. Okay, so again, the only thing left is if you look at this thing here and they ask you what kind of the graph do we have? Is this symmetric? Is this a skewed to the left or skewed to the right? Reminder, this is not symmetric, right? In order to be symmetric, it had to be somewhere, the highest peak had to be in the middle. So look at this thing here, the majority of the data appear to be on our left. Remember, if you look at this data, is on our left. But to know if it's skewed to the left or to the right is the opposite, or is the graph point of view, which is most of your data is on the right of the graph. The graph looking at you, which is on its right, which is looking at this thing here, this thing is skewed to the right. Okay, so if you go back to this question here, are the histograms skewed to the left, skewed to the right, or symmetric? Which is, again, this thing is skewed to the right. So reminder, I told you guys that when you, so for squareness of the graph is from the graph looking at you. The point of view of the graph looking at you is not from your point of view. Okay, so looking at this thing here, first of all, question with how I come up with my frequency distribution table, relative frequency distribution table versus my histogram, and how to determine if it's skewed to the left, skewed to the right, or symmetric. Any questions so far? And any question with this item here? So if you don't have question, there are a few more graphs that we have to look over, which is in 2.3, which is the last section of chapter 2, which is we looking at the stem and plot, stem and leaf plot, which is if you came from 120, you know how to do the stem and leaf plot, which is the stem is considered the last digit, and the leaf is the last digit, and the stem is the rest of the digits, right? Which is looking at this thing here, the smallest unit or the smallest digit is 8. That will be your leaf. Everything else will be your stem. And same thing go, the 9 will be your leaf and everything else will be your stem, right? So looking at this item here, your stem will be the whatever left over after you delete the last further right digit. Or again, if look at my data. So if I give you this data, if you can see my data is I have a 10 digit and the 1 digit. So looking at this thing here, my stem will be my 10 digit and my leaf will be my 1 digit, right? So I don't have any 100. So again, my leaf will be the last number, which is the 7. My stem will be the 5. So if you glance through this thing here, you can see that if you glance through this thing here, the smallest data is in the 10, in the 10, and the highest data is in the 50 range. So I don't need to go more than 50 because I don't have any other data more than 50. So again, this is in the 10, this is in the 20, this is in the 30, this is in the 40, and this is in the 50, which is my smallest data is 11 and my highest data is 57. So I don't need to go further than that, right? So to construct the stem and leaf plot, the only thing you need to do is basically you go into each of your data, which is my first data is 57. I go to the 5 and I roll the 7. My next data is 20. I go to the 2, I write a 0. My next data is 27. I go to the 2, I write a 7. My next data is 16. I go to the 1, write a 6, and 11 and 12. So again, those are basically, again, I work from left to right. I just basically take one data at a time. My next data is 29. I go to the 2, I write a 9. 39, I go to a 3, I write a 9. 45 and 52, which is, again, basically you go into each of your data and you write one number at a time. So again, my first 10 data, and this is my first 10 data here. And as you can see, you can keep on going, which is 58. We go to 5, write 8, 15, 46, 27, 22, 21, 15, 50, and 16, which is again, that's how you read it, which is again 16, 11, 12, 15, 15, 16. So in the sense, this is all we do is we go to each individual data and you write in your number. So in the sense, the only thing different is this: if I were to give you the test and I will accept this stem and leaf plot. The only thing is, because of our situation, your test, your quiz, your homework is on Connect Math. And the problem with Connect Math is they need to be in order. Your stem and leaf plot, your leaf have to be in order from smallest to largest. So if you give them this stem and leaf plot, they will tell you it's wrong because it's not in the order, the syntax that they want. So make sure you have to put in order, which is you have to put 1, 2, 2, 5, 5, 6, 6. Basically put them in ascending order from smallest to largest, okay? So again, Connect Math does not accept this stem and leaf plot. It has to be 0, 0, 1, 2, 7, 7, 9. It has to be from smallest to largest, okay? But to construct the stem and leaf plot, hopefully you guys see that to construct the stem and leaf plot, all you need to do is go to each individual data and write a number on your leaf, right? So if your data have in the 100 range, then over here you have 10. If it's in the 1,000, you have the 100 at your leaf, okay? So first of all, question with the stem and leaf, how to construct the stem and leaf, or how you have to type in your Connect Math. And then question here. Now, what is the purpose of the stem and leaf plot, right? What is the unique thing about stem and leaf plot? Well, one thing is the stem and leaf plot, ladies and gentlemen, is basically it's just like a sideways histogram. If you were to take the stem and leaf plot and turn it sideways like this, if you were to turn it vertical like this, you can see that this is literally like your histogram, right? If you were to draw a ball, this will be your ball. If you were to draw a ball, this will be your ball, right? The only thing different about this thing here, or the unique thing about the stem and leaf plot, is you know exactly what is your data, right? Looking at this thing here, if they were to ask you for a histogram, you would say, this is 3, this is 3, this is 5, this is 7, 7, right? The frequency, right? But if I ask you, well, how many students score 19? You would say, well, I don't know. If you look at the histogram, you would say, I don't know, because all I know is I have 7 students score between 10 and 20, right? Between 10 and 20, I have 7 students, right? But I don't know the score. But if you look at the stem and leaf plot, you can see exactly what the score is. We can see that there's no student score 19. We have 1 student score 11, 2 students score 12, 2 students score 15, and 2 students score 16. We don't have any students score 19, right? So that's the unique thing about stem and leaf plot, is it looks like a histogram horizontally, but it also gives you an idea of the exact unit, exact score, rather than tell you how frequent does the data appear, okay? So that's the unique thing about stem and leaf plot. And if you came from 120, you already saw this thing here. The only thing different in 120 versus 203 is now in 203, we have this called back-to-back stem and leaf plot, meaning we want to compare 2 data. We put those 2 data back to back. And the tedious part of this back-to-back stem and leaf plot in your Connect Math is this. If you look at this data, you can see that the smallest data, they are nice to you guys. They put them in order for you. 45 is the smallest data, 91 is the biggest data. And if you were to do the stem and leaf plot, which is, again, we have a 5, 45, 57, 62, 66, 68, 69, right? 72, 74, so on and so forth, which is, again, if you put this thing here, this is what I mentioned before, is you have to put them in order from a smallest to the largest. And now if they give you the next data, which is this is my history class, the only thing is now for your history class, when you put them, you have to put them in order from left to right, from largest to smallest. Or if you want to think about this thing here, is you start whatever your stem is, your stem will be in the middle here, but your leaf is basically going outward. We start in the center small, and the way further away from the center, the bigger the data get. Just think in the way that, again, on the left-hand side, it had to be basically start in the middle, smallest to the largest on the right, and on the left, it had to be largest to smallest. Okay, so they are very tedious in the way that it had to be this way. Whatever on your right, like this side, is from smallest to largest. Whatever on the left is had to be, again, largest to smallest, if from left to right, or start from the center, go outward, smallest to largest. Okay, so if you don't put them in this order, Connect Math will tell you it's wrong, and that's the only tedious or frustration part of this stem and lip plot, is when they have a back-to-back. Make sure on your left is, you know, from high to low, from left to right, and on your right from low to high. Okay, but to construct them is not difficult. Just make sure you have the right data on the class. You know, they may have freshman here and sophomore here, and you put the sophomore data on the left and the freshman on the right. So make sure the class that they give you, you have the right class, and just put them in order. That's one of the tedious part of the stem and lip plot that a lot of students do get frustrated, is the back-to-back. The last two items we have is the dot plot. And just like the name, the dot plot is basically we take a dot and we represent your data. So if this is my data is the number of children each of the president have during their presidency, right? So looking at this thing here, basically all you do is you look at this thing here, the smallest number of children is 0, and the highest number of children is 15. If you look at this thing here, all they do is basically you list out the number of children, and then each number of children you just put a dot, right? Looking at this thing here, I have 1, 2, 3, 4, 5, 6, 0, and that's why at 0 I have 6 presidents have 0 children, right? So again, 1, 2, 3, 4, 5, 6, which is each dot represent one data. In this case, I have 6 dots, right? And again, as you can see, if they were to ask you what kind of data do we have here, which is, do you agree that we have a skew to the right? Again, reminder, skewness of the item is opposite of what you're looking at. If you look at it and it's on your left, meaning it's skewed to the right. And again, they are not symmetric unless this thing here is somewhere in between here, then they will be symmetric. But looking at this thing here, go back to dot plot. Question of the dot plot here. Question of how to perform a dot plot. Again, just like the name, put a dot, plot it. And lastly, we have a time series plot. The time series plot, the only unique thing about the time series plot is whatever you do is have to be related to time. Meaning it's either in years, in month, in date, in hour, in minute, in second. Anything related to your time will be your time series. So we just want to show at particular time, most of the stock market, right? That's the time series, right? Within each hour, do they increase or decrease, right? So the time series plot is mostly is for that item. It's basically for that item in the sense that we want to know from years to years, do we increase or decrease the item that we have? Okay, so the one thing that on Connect Math, if you have not encountered the time series plot, is a little bit tedious in the way that you have to choose the time, which is for instance, right here, you have to choose from 2000 to 2001, and then you have to plug from left to right. You have to plug in this point, going to this point, and then you have to choose from 2001 to 2002. You plug this point, go to this point, so that Connect Math can draw the line for you. So make sure you have to choose from left to right. You cannot plug the right point, go back to the left. Connect Math, the syntax and the algorithm does not recognize that. Okay, so make sure you choose from left to right, left to right. Okay, so looking at this thing here, question with the dot plot or question with the time series. Again, the time series is just basically in this series of time, what is your increasement or decrease and stuff like that. And I think on your homework, they ask you what is, if you look at this time series and they ask you between what years is the most decrease, right? And you can see that between 2007 to 2008 is the big drop, which is the biggest decrease of all, right? This thing is decreased, but it's not that big of a drop within 1 year, right? And they ask you what's the highest years that the stock have, which is again 2007 is the highest peak based on this data, right? So again, you can look at this thing and answer those questions. But again, looking at this thing here, question with time series or dot plot or the stem and leaf plot. Any question? Well, if you don't have question, that is the end of chapter 2. Do you guys see chapter 3 on your screen? Does everybody see chapter 3 on the screen?
Yes.
Yes, we see it.
Okay.
Yes.
All right, because earlier I did it and they don't see it. Okay, that's good. So it's worked now. So let's take a look at chapter 3. If I mentioned your first test is chapter 1, chapter 2, and chapter 3. And like I mentioned, the only thing in chapter 1 is a lot of definition. Chapter 2, you still have that small calculation of a relative frequency, not that many calculation. Chapter 3, this is where we start to do a few calculation. And this is where your calculator will come in handy. So 3.1, this is what we have is we want to measure the center of our data. We want to measure the center of our data, and the center of the data, we will have the mean, which is to find the mean just like before. If you remember how to find the average, that is basically the mean. They just change it. Instead of find the average, is to find the mean. So to find the mean, all you need to do is take each of your data, add them up, and divide it by the total number of data. Make sure, ladies and gentlemen, make sure to remember your notation, which is again the X bar. The X bar, that is your sample mean. The mu, this is, we call it mu, which is again is like a U with the tail. Mu, we call this a population mean. To calculate them is the same. Just take each of your data, add them up, and divide it by the total number of data. The reason why I emphasize this thing here, because later on, that's what you have to know the difference between the notation. Okay, the rule of rounding. The rule of rounding, like I mentioned, is in this class we have a few different rules, which is again, if we deal with a discrete data. If we deal with discrete data, you always go up to next whole number. And reminder, discrete data is your counting data, right? 0, 1, 2, 3, 4, right? The number of people. So if we deal with discrete data, you always go up to next whole number. The other one is if your data, if Connect Math tell you to cap how many decimal they want it to be, if they don't tell you, you have to cap one extra decimal than your data. If your data is a whole number, you kept one decimal place. If your data have one decimal place, your answer will be 2 decimal place. If your data have 2 decimal place, your answer will be 3 decimal place. Okay, so again, that's the rule of rounding, which is ConnectMath will tell you how many decimal they want. If they don't tell you, you have to keep one extra decimal place. The other thing that we have, which is again the mean, the median, which is the median is we measure the position of your data, and the median is the middle position. And to find the middle position, this is the only thing that you need is, first of all, your data have to be in order. It had to be from either from smallest to the largest or from largest to smallest, okay? Once your data is in order, if you have an odd number of data, the middle number is your median. If you have an even number of data, you have to take the middle two number, add them up and divide it by 2, right? To find the average of the middle two, you add them up and divide it by 2. So that's your median, which is there's no calculation unless you have an even number of data. But to calculate them is very easy. Take the middle two, add them and divide by 2. And the last thing in terms of the middle or the center of your data is your mole, which is the mole is the most frequent data, meaning whatever data appear the most frequently, that will be your mole. So looking at this thing here, this is what we have in terms of the mole. You don't need to calculate, you just look at your data and then you ask yourself what data appear up the most time. And lastly, you will see this thing later on a lot, which is resistant. They say that the median is resistant, meaning basically tell you that if we have an outlier, which is an extreme value, it will not affect our data. It will not affect our median, because the median, we just measure the position of your data. So to measure the position of your data, the resistance will basically, your outlier will not affect the position. Your mean is not resistant because your mean, the outlier will affect them a lot. And we will mention more when we get to outlier in 3.3. But for now, just know that the median is resistant, okay? So looking at this thing here, let's do some example. Let's say if I give you this data and I ask you to find the mean, the median, and the mode. So to find the mean, basically, hopefully you guys see, to find the mean, all you need to do is take each of your data, add them up, and divide it by the total number of data, which is in this case, the total number of data is 6. So again, I have 6 data. I take each of my data, I add them up and divide by 6. And if I do that, which is again, I add them up, I have 10 divided by 6, I have 1.666666666. And again, I need to round up to one extra decimal place, which is 1.7, which is again, that is my mean. And to find my median, reminder, the most important thing about median is the first thing you need to do is you need to put them in some kind of order, which is the order we have. For me, I put from smallest to largest. And all you need to do is go in and mark them out. And basically, as you can see, we have 6, which is we have even number. And if we have even number, we need to take the middle 2, add them up and divide it by 2. And if I take the middle 2, add up and divide by 2, my median is equal to 5, which is my median is somewhere between -5 and 15. Remember, it's -5, so it's basically 20 units, right? So 5 is between here, which is I have 3 data to the left and 3 data to the right, okay? So that's your median. Because we have a even number, I need to take the middle 2, add them up and divide it by 2. And to find a mole, pretty much it's very easy. To find a mole, you just glance through your data and ask yourself what data appear up the most, which is 20 appear up the most. That will be my mole. So again, looking at this thing here, any question of how to find the mean, how to find the median, and how to find the mole. And now, if you don't have those questions, one good thing about this thing here is your calculator can help you to find the mean and the median, Okay, so you looking at this thing here, and again, I know you can do this by hand. It's only 12 data, I think. It's only 12 data. You can add them up and divide by 12. You can put them in order and mark them out. But again, because like I mentioned, this class is a little bit technology driven, so we can use the technology to help us to save some time. And this will save a lot of time, right? So one thing is, let me ask you guys, is anyone in this class have TI-83? Anybody have TI-83 in here?
I do.
Okay. So if you have TI-83, I will use TI-83 as a demonstration. Whoever have TI-84, it will be a little bit easier on your part because TI-84 is a little bit advanced, which is they give you better, easier access. But again, either one, you still do the same. All you need to do is you need to press stat in your calculator, which is, let me show you. Why is so let's see. So this is your TI-83, right? So if you have your calculator, and again, TI-83 and 84 is the same. It's the same function. It's just that 83 you have to manually type it in. And I show you how to type it in. But again, for now, if you have your calculator, this is what you need to do: is you need to hit stat, and in stat you have 3 items here, which is you have edit mode, you have calculation mode, and you have a testing mode. But for now, we need to, before we can tell them to calculate, we need to edit them. And if you edit them, which is again, you choose edit, you hit enter. This is your L1, L2, L3. Make sure you have L1, L2, L3. So once you're in edit mode, this is all you need to do is just type in your data, -7. Make sure you use the negative sign. So let me use -7, 3. Let me type this thing in, bear with me, 19, 17, -9, 15, 3, 0, 10, 3, 7, and -4. So again, if you type in, looking at this thing here, the L1 12, which is again, I have 12 data. Like I mentioned earlier, this is my 12 data. So I type in, and again, one thing about calculator driven is you need to be very careful in terms of what you input, right? Again, the calculator is just as good as the user. So if you type in the wrong data, the calculator will give you the wrong output. Okay, so make sure you type in the right data, which is in this case, once you type in the data, once you type in your data in L1, make sure it's in L1. All you do is you hit stat, and then you go over, scroll over to calculate, which is, this is your calculation. And for us, we will use one var stat. We have one variable, one var stat. We never use 2 variable for us. So one var stat, which is option number 1, you just press enter. If you have 83, this is what you see on your screen, which is one var stat, right? If you have 84, if you have TI-84, you will see this window prompt. You have this window prompt, which is you have the word list, you have the word frequency list, and you have the word calculate. So if you have the TI-84, make sure in your list you have L1, and your frequency list, make sure it's blank. So go there and clear them out or delete whatever your frequency have. Usually your frequency have L2 as of now. If they have L2, make sure you leave it blank or clear it. You should not have anything in your frequency list, and then you go down and you select calculate. If you have 83, you just need to press enter, and then they will give you the answer. Okay, so 83, once you hit, again, for 83, once you go to calculate, you choose number 1, and then you press enter, and you press enter again. This will be your output. Okay, so let's take a look at our output. What is the unique thing, or what is the thing that we need for our output, or what does the output tell us? So the output tells us this item, like right here, ladies and gentlemen, X bar. If you remember X bar, what is X bar? X bar is your mean, right? Your population mean and your sample mean is the same. So again, X bar is your sample mean, but again, this is my mean, which is 4.5. Everybody have that on your screen, 4.5. And if you scroll down, to your M.
Sorry, Professor. You mean 4.75?
Yes, 4.75.
Okay.
Yes. Just make sure that you're still awake in my class. Just kidding. 4.75. If you scroll down, if you scroll all the way down, you will see that MED, which is your median. You can see that again, your median is 3, which is that is your median. So your calculator give you 2 items, which is they give you your mean and they give you the median. They give you more than 2, but we'll go over the other thing later. But for now, the 2 items for this particular item, is that we need, which is the mean and the median. Okay. So question with how to input your data. Any question here, how to use your calculator to input your data to get this screen? And again, this is what my 84 calculator look like, which is again, it's the same output as the 83. The calculator is the same. It's just that when you type in your 84, you have a window prompt, and 83, you have to manually type it in. Okay, so first of all, question with this particular problem, how to identify your mean and your median. So the reason why I show you this thing here is not for that problem. That problem, you can do it by hand. The reason why we use the calculator, a lot is because we have, most of the time, you have a group of data. Right? You have a group of data, which is, if you remember, when we start this class, we start with that frequency distribution table and your frequency distribution table of the class. And sometimes, you know, when you look at your class, you don't know your individual data. And if you don't know your individual data, how can we find a mean if we don't know our individual data, right? So looking at this thing here, they tell you that if we have a group data, we cannot find a mean, we can approximate the mean, right? We can approximate the mean and we can approximate the median. But to do that, all you do is, this is the first thing you need to do, is we need to find a number that represents that class. And to find a number that represents that class, what we do is we take the midterm, the midpoint of each class. And for this author, he said to find the midpoint, you take the 2 class, you take the 2 consecutive lower limit, add them up, and divide by 2. Okay, so basically that's what he tell you is, to find the midpoint, to find a number to represent a class, we need to take the 2 consecutive lower limit, add them up, and divide by 2. Okay. So if we were to, for instance, let's take a look at this problem here. So this problem, this is the frequency distribution table they give you, right? We have a class between 0 to 15, 16 to 31, and so on and so forth. So looking at this thing here, and you look at the frequency, you can see that in this class is between 0 and 15, meaning there are 16 individual items, 0, 1, 2, 3, 4, 5, 6, 7, all the way to 15. There are 16 individual items, but they only appear up 2. So what data appear? We don't know the data. We don't know, is it 11 and then 14, or is it 2 and 9? we don't know which two individual data appear. We just know that between 0 and 15, there are 2 items. Between 16 and 31, there are 14 items. So we don't know exactly what data appear, right? They only give us the frequency. So that's the reason why we need to find the midpoint to represent that class, which is to find the midpoint. This author, he using to find the midpoint, we take the 2 lower limit, the lower limit of the first class, which is 0, the lower limit of the second class, which is 16. You take the 2 lower limit, 2 consecutive lower limit, add them up and divide by 2, which is, as you can see, we have 8 as our midpoint. And let me ask you, what is the class width? If you look at this thing here, do you agree that every time you jump from the first class, we jump to the second class, every time I jump, I add 16. Every time I jump, I add 16. Every time I jump, I add 16. Every time I jump, I add 16, right? So every time I jump, I add 16, which is, look at this thing here, my class width is 16. The reason why I mentioned that is because if you can find the first midpoint, you just apply the class width, because every time you jump, you just add 16. Every time you jump, you just add 16. Every time you jump, you add 16. Every time you jump, you add 16, which is, looking at this thing here, will be the item, right? Yeah, you can take 16 plus 32 divided by 2, you still get 24. You take 32 plus this, you divide by 2, you still get 40. But instead of doing that every time, we can see the class width, and every time you jump, you just add that many units. Okay, so again, first of all, question how to find the midpoint for this book, for this author. The reason why I mentioned this book and this author, because he do a little bit different than when I learned. When I learned this class, they tell me take within the class, take 0 plus 15 divided by 2. And the reason why I think the author doesn't like that, because it will give you the decimal. But anyway, because we use this book, so we have to use this author, because connect math based on this author item. So I show you this author method. But again, first of all, question of how to find the midpoint here. Now, once you find a midpoint, this is what you need to do, is you need to use your midpoint. You type your midpoint in as your L1 item, and you use your frequency as your L2 item, which is, again, my midpoint, my data, my midpoint will be L1. Now I need to type in the frequency, which is type in L2. And again, once you have this thing here, everything should be the same, which is, looking at this thing here, if you have this data, so let's take a look at this item here. So looking at this thing, let me clear this. One thing, ladies and gentlemen, if you want to, looking at this thing here, for L1, right now your L1 should have something in it, which is the previous problem. If you want to clear L1, make sure that you go in and highlight L1 and you press clear and press enter. If you go and highlight L1 and you press clear and press enter, they will clear your L1 item. Do not press delete. If you press delete, you tell the calculator to delete the whole L1, you will left with no L1. So make sure do not press delete. You have to press clear and then enter, okay? So looking at this thing here, this is what you need to do in L1. You need to type in your midpoint, which is your midpoint is 8. Every time you jump, you add 16. So again, you can press 8 plus 16. If you want to, you can press 8 plus 16 to give you 24, or you can just manually add 16 to yourself, which is again 24 plus 16 to give you 40, 40 plus 16 to give you 56, and 56 plus 16 to give you 72, which is those are my 5. I have 5 items, which is those are my 5 midpoint. Everybody see my midpoint is 8, 24, 40, 56, 72. And on L2, you need to type in your frequency, which is your frequency is 2, 14, 6, 13, and 15. Again, one thing is make sure that you have the right frequency for the right midpoint. That's the one careless mistake a lot of students do, is they mix and match the frequency. Make sure that your data and your frequency line up. Again, 8 is my midpoint. I have 2 as the frequency. 14, 24 is my midpoint. 14 is my frequency. 40 and 6 and vice versa. Make sure that you have those items. So once you have this thing here, you hit stat one more time. Once you type in your data, you hit stat one more time, and you tell your calculator to calculate this, which is, again, if you have 84, this is the window that you will see this prompt, which is you have list. Make sure in list is L1. Your frequency, you have to type in L2 and then calculate. How do you type in L2? You hit second, number 2. Everybody see your calculator, you have all that yellow item. To access the yellow item, you have to hit second and then whatever the item you have, okay? So 83 people, if you have 83, this is what you need to do, is you need to hit second, number 1. You need to tell your calculator, I have my data in L1, comma, the comma is right here, second, number 2. So basically you tell your calculator, my data is in L1, my frequency is in L2, use that data to calculate for me. Reminder, to hit L1, you hit second, number 1 to access L1. To type in L2, you hit second, number 2 to L2. If you have L3, L4, so on and so forth. And again, to access the green item, you hit alpha. But again, for now, we're using the yellow item here. To get the yellow item, you hit second, that item. So again, you just, for 83, you hit L1, comma, L2. And then you press enter. They will give you this item here, which is, as you can see, my answer is 48, which is my X bar, which is my mean is 48. And if you go scroll down, if you want to scroll down, your median is 56, but they don't ask you for median, they just ask you for the mean, which is the mean is 48, which is, again, anybody did not have the screen that I have right now. Everybody got this output. And again, that's how easy it is to find the mean, right? Your calculator can do the work for you. And reminder, in order for the calculator to do the work for you, you have to tell the calculator what to do. So again, like I mentioned, the calculator just as good as the user. So if you type in the wrong item, your calculator will give you the wrong answer. And that's the bad thing about the connect map, right? You do it and then you type in the wrong one, you type in is wrong, you're like, what did I do wrong? Again, make sure to know how to use your calculator. So question with this thing here, question with this item we have, how to find the grouping, right? Again, if you look at the book have if you do it by hand, it's a little bit tedious to do it by hand. And again, the reason we have the calculator, we don't need to do it by hand, okay? So if you still have problem with your calculator, make sure that you know how to do it. Ask me a question. If not, I assume that all of you guys know how to use your calculator. Any question with 3.1? That is the end of 3.1. 3.2, 3.2, now we want to measure how spread out of your data. We want to know how spread out, what is the spread of your data. So the first thing we measure is we want to find a range. And to find a range is very easy. All you do is you take the highest data minus the lowest data. It's basically asks you between the lowest value to the highest value, how far apart are they? How many steps do you need to take from the smallest data to the highest data? Okay, so the range is easy. The next thing that you have, ladies and gentlemen, is the variance. The variance is basically how spread out is your data. What is the spread out of your data, which is, again, your variance. Make sure, like I mentioned, the hardest, not the hardest, but one of the tedious thing in this class is make sure to recognize your notation. Excuse me. Make sure you recognize your notation, which is, again, the variance notation. Instead of a mu for your population mean, your variance is your sigma. It's like a canon, sigma square. So again, this sigma is your population variance, and your sample variance is just a S, okay? Sample variance will be S squared. So this is the formula to find the population variance, and this is the formula to find the sample variance. The only thing different is you need to divide it by n-1, because the n-1, because of the sample, we cannot take the whole entirety of all of your data, which is your sample is we have to take a portion, which is we have to take one less than the whole data. But if you came from 120, and I saw some of you took me from 120, you remember that 7 or 6 steps to find the standard deviation, right? In this case, they give you the 5 steps to find the variance, which is you need to find the mean, you need to take the data, subtract the mean, you need to square them up, add them up, divide by n, if it's population, divide by n-1, which is the sample. And then to take a standard deviation, to find the standard deviation, you just need to take a square root, right? So again, if you see that I go a little bit fast with this thing here, because in this class, you probably won't do it by hand. You probably don't do this thing by hand. But again, let me mention this thing here first, and then we would do this using your calculator. Like I mentioned prior, the difference between the standard deviation versus the variance is if you have the variance, all you need to do is take a square root of the variance, then you get the standard deviation. So whatever your variance is, you take a square root of that. So if they ask you to find the variance, you know, the item is your variance. If they give you the variance and they ask you to find the standard deviation, you take a square root of the variance to get your standard deviation. And the standard deviation, ladies and gentlemen, is basically the average difference, the average spread out of all your data from the mean. Okay, remember the variation is how spread out your data, how spread out of each of your data, how far apart of each of your data, right? And the how far apart of each of your data to the mean, and the standard deviation is what is the average difference of all that spread out. Okay, so let's take a look at this thing here, and let's say if we were to have this data, find a range, the sample variance, and the sample standard deviation for this item, right? So again, they give you, they ask you for a sample, so make sure, you know, read your question carefully. Are they ask us for the population, or are they ask us for a sample? So we won't do this by hand. Well, the range is easy. We take the highest minus the lowest, right? We won't do this by hand. Let's take a look at our item and how to do this with our calculator, right? So look at this thing here. This is my data, Let me turn this thing on. So if let me clear this item. So make sure that to find the variance and to find the standard deviation, ladies and gentlemen, the first thing we need to do is the same. We need to put in your data. We need to put in your data, which is, again, ladies and gentlemen, if you remember to clear this thing, if you want to clear L2, you go to highlight the L2 and then you click clear. You can clear each individually. If you want to clear the whole thing, you have to go to L1. You highlight L1 and then you press clear and then you press enter. which is they clear everything else. Don't click delete. Don't ever click delete. Click clear. So everybody see that I clear my item. So if I want to find this item here, which is all I need to do is type in 16, 6, 18, 25, and 22. So again, I have 6 data, which is, this is my, I'm missing a data. I'm missing a 3. Again, the reason why I know I missed the data is everybody see right here, they say L1 number 6, meaning at this location is number 6, meaning I only have 5 data. I have 1, 2, 3, 4, 5. I only have 5 data, but in this case, I have 6. So I'm missing a 3. So again, make sure, that's one thing, is make sure you have all of the data, right? So again, this one here is easy because we have 6 data. It's easy to recognize. L1 is 7, meaning again, at location is number 7, meaning I have 6 data above. So again, 16, 6, 18, 3, 25, 22. So those are my data. This is what you need to do, which is again, once you have this item, all you need to do is hit stat one more time, go to calculate, and then use the 1 var stat. It's the same item as you've been using. And on your first test, this is the only item we're using, which is the 1 var stat. So we're using the 1 var stat, which is again, 1 var stat, you press enter. And looking at this thing here, this is what you have. Ladies and gentlemen, you have, we know that this is the mean, but now looking at this item here, let me ask you, or let me show you, they have, do you agree that we have an S and then we have a sigma? We have these 2 items. We have an S in yellow and we have a sigma in red. Remember, what is my S? My S is a sample standard deviation. My sigma is the population standard deviation. So your calculator gives you the standard deviation. Your calculator gives you the standard deviation, ladies and gentlemen. So life is good, right? If they ask us for a sample standard deviation, my sample standard deviation is 8.7. My data doesn't have a decimal, so 8.8, right? My sample standard deviation. So what is the relationship between a sample standard deviation versus a sample variance? Reminder, if they give you the variance, we take a square root the variance to give us the standard deviation. But if they give us the standard deviation, how do I find the variance? Well, if you look at this thing here, if they give us the sample, or if they give us the standard deviation, everybody see that if they give us a standard deviation, all we need to do is take the standard deviation and square them. If I take the standard deviation and square, I will get the variance. And yes, ladies and gentlemen, the variance is always bigger than the standard deviation. The variance is not double, but square of the standard deviation. The other thing I want to point out is this. Make sure when you do the calculation, make sure to use as much decimal place as you can. To be safe, use at least 4 decimal place. Because don't use 8.8. Because if you use 8.8, your answer will be wrong because you estimate them. And when you estimate them and then you square them up, you get a humongous number. Okay, so looking at this thing here, your calculator give you the standard deviation. They give you the sample standard deviation and they give you the population standard deviation. If they give you the standard deviation, to find a variance, you take the standard deviation and you square them up, okay? And your calculator do not give you the variance. You have to be a little bit better than your calculator, which is you need to maneuver. If they give you the standard deviation, you take the standard deviation and time itself, which is you square them. And if you square them, you will get the variance. So that's why if earlier, if you say, why did I go away from this item so fast? The reason is we don't need to do this by hand, right? This thing here is just if you do it by hand. Now your calculator can calculate for you. And if they can calculate it for you, might as well use the calculator, right? It will save you a lot of time. So, but the bad thing about a calculator is, the calculator do not give you the variance. You have to find the variance, and to find the variance, you have to take the standard deviation, square them up, okay? Question here. Question of how to find a variance if they give you the standard deviation, because your calculator, reminder, your calculator only give you the standard deviation. Your calculator can only calculate the standard deviation. You need to take the standard deviation and square them to find the variance. And again, your homework question asks you that. The homework question asks you for variance and standard deviation. And make sure if they ask you for sample, you have to use the sample. If they ask you for the population, you have to use the population. Make sure that you're using the right standard deviation to find the item, okay? And if you look at B, right, B, I asked you for population, so that's why over here I'm using the population and I'm not using the 18.817, right? I'm using 17, which is my population standard deviation, okay?